everyone, I'm Charlotte Kilpatrick, reporting for Vaccine Nation from the World Vaccine Congress in Washington. I'm delighted that today we're joined by Dr. Antu Dey of AstraZeneca's, which is part of the AstraZeneca group. Thank you so much for your time. So to kick us off, would you kindly just introduce yourself and the role that you play within your organization?
Sure, an absolute pleasure. I'm Antu Dey. I head preclinical vaccines within AstraZeneca's, which is now part of AstraZeneca, and have the pleasure of leading the discovery and the research effort for making the variant vaccine candidates that will take forward into first animals and then into human studies.
Fantastic. So you're joining us to discuss a novel VLP platform technology for the development of vaccines against emerging and re-emerging diseases. Can you give us any insight into this session?
Oh, sure, absolutely. So it is truly a novel VLP platform technology which came out through a translational collaboration between the Gates Foundation and David Baker and Neil King's lab at the Institute of Protein Design, University of Washington. And what then happened is just what seemed to be really a fascinating protein-based nanoparticle technology has revolutionized how we can present, antigens from various pathogens, be it viral, bacterial, or others, into this, protein nanoparticle, which we're calling VLP, that has demonstrated to generate, really strong vaccine immune response against those targets. And that's what is now at the very backbone of the bivalent vaccine AstraZeneca is taking forward into a pivotal phase 3 trial. And we are working on other targets using the same VLP platform for other indications.
Fantastic. So you just mentioned some other targets. May I ask about the greatest challenges that are associated with developing vaccines for emerging and re-emerging diseases?
Well, very important and timely questions. So when a pathogen emerges in human, it is a challenge because we as humans have not seen the pathogen before. So it is all of the discovery and invention efforts to develop the vaccine against the pathogen. So to start with, that's a challenge, but it is just the beginning because thereafter, as these pathogens interact with the host and have, interaction with the environment around, they mutate, they change, they alter. And as they alter, they pose challenges to the vaccines that we developed at the very beginning, and therefore we need to adapt. And what we face is the same challenge that everyone else in the vaccine field faces, which is how do you adapt your vaccine to these re-emerging pathogens as they come and interact with, human host system. So what we do is look into those changes that are happening in the pathogen, particularly in those proteins that mediate, entry into host cells, and ensure that we're updating our vaccine, antigen, so that now the protective mechanism is updated as well to protect from these re-emerging pathogens.
Fantastic. So you just mentioned updating. Can you tell us a bit more about how your team responds to the challenges you've just mentioned? What's your approach to overcoming them?
Yeah, so here we have to be a little bit technical. So what we do is look at the evolution of the pathogen. At the same time, we now drill down into the impact of this evolution that is happening as a result of the environment and the host interaction, and then go into the changes that are happening in the pathogen. And those changes, which are necessary for us to keep in mind as we make the vaccines, we look into those changes and then drill down to see what elements we need to keep in consideration as we update the vaccine. So we go into what are called conserved epitopes or regions within the antigen that need to be maintained. And then the vaccine antigen need to be presented in a way where those conformational pockets or epitopes are presented, and so that our immune system can then elicit response that can then mediate in blocking the pathogen's entry into our host cell. And at the same time, these antigens, sometime as the evolution happens, these antigens become more and more difficult to make, either from an expression standpoint or from a stability standpoint. So my team spends an incredible amount of time in understanding those changes and how those changes not only impact the pockets or the epitopes that have altered, but also how those changes now impact expression difficulties and conformational stability difficulties. And then we try to bring in protein changes or protein engineering changes into those antigen, stabilize them, and then update our vaccine coding. And you'll see some of those examples in my talk later today.
Fantastic. So you just mentioned your talk, which is obviously a really exciting opportunity for our colleagues to hear from you. But what are you hoping to achieve from your time here, and what are you most looking forward to?
Great question. It's a two-way. One, I'm trying to share our journey, what we have achieved with the platform in itself, and also the potential beyond what we have done today. So that's one part of what I want to engage. The second part is to learn from what they have been doing and where their learnings from what they have been doing, in particular around the emerging diseases and as I mentioned about the re-emergence of those pathogens and the challenges they have faced, which is a common challenge for us, and how they've been adapting. So that should help us, either to collaborate or to have those learnings into our vaccine design to take things forward.
Fantastic. Well, I hope you have a very productive and collaborative time here. Thank you for joining us.
Sure, my pleasure.